Hi, I'm trying to make a new type of video that is simply working on a past paper in a year. And so you can try to do this paper by yourself, and you may want to see how I would do it as well and how I will explain it. I guess what I'm doing is I will be doing the paper by myself, and then I will check the marking scheme by the end just to make sure that my answers are correct. Okay, so what I put down earlier may not be 100% correct, just so you know. And yeah, we'll try to see what happened and see if you like this type of video. So the paper I'm trying is 2016 November SL paper 2. So if you want to try it as well, you can go and find the file and try it yourself. Alright, so let me start with the first question. Tennis ball is hit with a racket, so here is the height above. Okay, this is 1.5. Ceiling, okay, it's given in the table. And then initial velocity, okay, this is u. There's an angle. Okay, no air resistance. Determine whether the ball will hit the ceiling. So I think what you have to do is to check the maximum height. Okay, and so that is, you have to find the height maximum when v equals to 0, u equals to 15, and we're considering, of course, the vertical movement. So 15, that should be sine 50 for initial velocity. And then we want to find, okay, so acceleration would simply be g, which is 9.82 in IB. So if you don't remember the kinematics equation, you can go and check out the data booklet in chapter 2, and that should be v squared equals to u squared plus 2as. Okay, and then we just substitute everything in. U is 15 sine 50 degree square plus 2, and then G is, A acceleration is going down, right? So we should put negative. For G, I think they mentioned it in the cover, did they? No. So I think we would have to follow the one that they provide in here. Yeah, 9.81 is the one that we use in IB. So 9.81. And then h is the maximum height that we want to find. So press the calculator. Okay, I find h maximum to be 4.738 meter. Okay, and then don't forget, initially we have 1.5, so the total height is going to be 1.5 plus 4.7, yeah, 4.738 if you like to. So plus, answer plus 1.5, well, obviously it's going to be 6.24 only, so it's smaller than 8.0 meter, and so not hitting the ceiling, because it's obviously shorter. Okay, so this is part A. Quite tedious, right, for 3 marks. Part B, the tennis ball was stationary before hitting mass. Okay, so we have got M, we've got another U, like before you hit it, 0. This is a time, delta t, so something to do with impulse, I could guess. Mean force, so that means average force. So just so you know, in your data booklet, there's an equation about momentum, okay, here. And for this one, you should notice that the force is actually the average force, because you're using delta P over delta T. So it's the idea of average, not instantaneous, unless you use differentiation, dP over dt. Okay, so we'll just be using that. F equals to delta P over delta T. Delta P will simply be mv minus mu, and u is 0, and so we simply have the mass the V which is given as 15, and delta T would be 23 milliseconds. So milli is -3. Again, calculator. So I get 34.8 Newton. Okay, that should be the answer. Okay, next part asks you explain how Newton's third law applied when the racket hits the tennis ball. So I think first of all you need to recall something that's related to the definition of third law. So it's definitely saying that the force acting on the ball by the racket and the force acting on the racket by the ball, so the two forces will be, or I should say must, right, must be in the same magnitude but opposite direction. I think that's it, right, for 2 marks. Yeah, I will check the answers by the very end after I finish the whole paper. So let's see. Question 2 looks like also about kinematics. So curling, actually I don't know what it is. Oh, so like the one with the eyes, and okay, it's very interesting sports in Olympia. So player push smooth, okay, on ice for several seconds, release it, blah blah blah, until friction bring it to rest. Okay, so there's friction. Okay, not much information provided here. So this is the diagram that we have. Total distance traveled by this is, okay, so that means the area is 29.8. Okay, asking you, okay, so obvious, yeah, very obvious, maximum speed. So so what we got is 29.8 equals to the area of this. So that should equal to a triangle area, which is the base times the height, which is phi, divided by 2. Okay, so you can resolve it using, again, calculator. So we should get 3.4057. So I will run it to 3 sig fix, so 3.41 meter per second. Yeah. B1, the stone has a mass. Okay, frictional force, find the F during this. Okay, so I think the friction is the only force that is acting on it. So that should be the net force. I think it's something to do with F equals to ma, because you could find the acceleration. Okay, or maybe there are other better method, but I guess that is going to work. So the friction is going to be the mass, and A is last 14, so that's it. That means this one, right? So that is obviously you can calculate by V minus U over T, right? And so the friction equals to 20. V is 0, U was the one that we calculated, so 3.41. I hope that was correct. And then the time they actually told you is 14, right? Or you can calculate 17.5 minus 3.5. That's 14.0. Yeah, I think that's probably the easiest way to calculate. So that will be negative 4.87, taking 3 sig fig. Part 2, determine energy dissipated due to friction. Okay, so I would say work done against friction equals to KE, because I think instead of calculating, I mean, you may be thinking of, work done, so force times distance, but then is that okay? I think that's okay, but then you have to evaluate the area of this, because this is the time when it decelerates. So you just have to calculate this, so that would work. But I think I would prefer doing KE simply, because that is supposed to be all the energy that you have initially. So that is here. So we could simply calculate half mv squared. For the mass we have 20, v we have 3.41 from the previous part square, and that should give you a much easier way to calculate the answer. So that should be 116.2x1, so 366 or 116 joule will be the final answer. Alright, next question I think is something to do with thermal, because when you see internal energy, and then here you see something to do with the gas, so like PV ideal gas law. So obviously this question should relate to chapter 3, thermal physics. So in terms of internal energy, I think I would say, again, I'm not 100% sure, consists or composes of kinetic energy and potential energy. Okay, but then there are 2 marks, so I think I might want to explain further. I don't think by just writing kinetic and PE will give you 2 marks. So kinetics is dependent on the temperature, which is the or the speed of the particles, or how fast they move. The more K you have, the faster you move. Potential energy is dependent on the force, molecular force. The magnitude, should I say? The magnitude of the molecular force. I think that's the best I can say. Okay, we'll see at the end. Part B is that they've given you the mole, so N. Okay, write the symbol next to it. Monatomic gas. Okay, so it's very simple form in a cylinder, fixed volume. So we have V, we have P here. Power analysis can use to state how internal energy of ideal gas different from the real gas. So you have to recall the assumption for ideal gas. So for ideal gas, it is assumed to have 0, because there's literally no intermolecular force. While for real gas, there is intermolecular force. So like what we mentioned earlier, due to this, then the potential energy of ideal gas is 0, hence the internal energy is less than the real gas. Okay, for if you are talking about the same one. Okay, I think that's all I can say. Although it's a lot of words for 1 marks. Alright, but if I could, and if I have time, and I think that's all I would say. Part 2, in Kelvin, find the temperature T. So obviously PV, NRT obviously. So I think when you see these PV NRT, you should be very happy. So 1.4, volumes 21. Just pay attention if they are in SI unit. Mole is 0.46, and then R is from the data table. R is something here, gas constant, so 8.31. I like to use bracket more. T, okay, and then they already told you is in Kelvin, so it's good. You don't have to convert anything. Just use your calculator. So temperature is 7.69. That's small. That's a bit strange. Did I? I don't know. Yeah, I think that is correct. Okay, I'll just leave it like this. But it's pretty low. I mean, 0K is absolute 0 already. Part 3 is something to do with nature of science because it asks you nothing to do with the content of the concept in chapter 3 or even with physics. It's more about asking you why kinetic theory of ideal gases as a scientific model will be useful. So I would say in general we create model, and then this is useful for interpreting what happened. So I would say I'll try to put down more reason than one, because they mentioned one, but then I'll try to blend it into one. Hopefully it kind of hit or meet what the marking scheme would want. Having a model can help scientists to visualize what happened microscopically and make it easier for communication and discussion. I think that's is what I will put. Yeah. Next up is something to do with quantum physics in chapter 7, obviously. So it has K meson, giving you the content, state the charge of this meson. So you just have to check. So charge number, I'll try to make it better in presentation. We just have to check in data booklet. I can't remember that too. So right here, so you have NT up, right? So that is here you got positive 2 over 3, so NT will be negative 2 over 3 plus a strange negative 1 over 3. So in total you have negative 1E. Okay, here we've got a Feynman diagram and some blanks. Obviously I think we have to fill in, yeah, 4 missing particle symbol. So we have a neutron, proton, you obviously have to realize, and in case you don't remember their content, then you can check by recalling their charge. So for example, U is again positive, I'll just write here, and then down is negative 1 over 3E, right? Up and down, yeah. So for neutron is 0 charge, so you need another one that's negative 1 over 3E, so that will be down. And for proton it will kind of be opposite, so it will be U, so then it will be positive 2 over 3, negative 1 over 3, positive 2, and that add up to be 1. Yeah, that's right. Okay, so of course I shouldn't be drawing these things to distract the marker. Okay, so I will erase it. And then here you will have to determine, sorry, I have to write again. So down is negative 1 over 3 E. This is positive 2 over 3 E. And so you have to think about when you look at the Feynman diagram from left to right, this is the direction you should read. And then this become positive. That means it should out something that is negative, right? So W minus should be the one, because we are involving beta negative, beta minus decay, so that will be a weak interaction, right? So you can choose either W plus W minus. So here it should be minus, so that now it will become positive afterwards, right, for the up quark. Here obviously, or if you simply recall beta minus, you know that is electron. All right, and that match with our idea, knowing that the electron is matching with anti-neutrino. Yeah. Part C asking you carbon is a radioactive isotope which undergo beta minus decay to stable isotope nitrogen 14. Okay, energy is released during this decay. Explain why the mass are slightly different even though they have the same nuclear number. I think there might be two approaches to explain it. One approach, which I probably don't prefer, is carbon and they have 14 nucleon, but then if you try to rule out how many of them there are, and obviously you should know that the reason why you have that electron from the beta minus decay is because you actually change one neutron into proton, and that electron got shooted out from the nucleus. So that's why in terms of nucleon number is still the same for carbon and nitrogen here. But then in fact, if you try to check the data table for the actual mass of proton and neutron, you know that neutron, when you try to add them up together, like electron, proton, this one, if you just add them up, they don't equal to this, right? That's why it's different. So I think this could be one way to explain. The other way to explain should be something to do with the binding energy. So since he said there's energy released, right? So then there must be mass defect. So I guess that would be the second approach that I would prefer, because I feel this is what they are looking for, all right, to be honest. And so that is kind of like an exam techniques. So probably what I would say is the binding energy is released in this reaction, so there must be, alright, by the equation, just in case they would want to see this. Alright, by this, there must be mass defect, right, in this reaction, so the mass would not be the same. Actually, this may not be a good approach, because we are just talking about the reaction, right? Because we have carbon 14 and then nitrogen 14 plus electron plus anti-neutrino. So what they want is this two, not the whole thing, right? So yeah, actually I think what I mentioned about the first approach would actually be better than this one. So probably I would scrape this. I would change to talking about yeah, what I mentioned earlier. Okay, so I probably just keep it like this, and we'll check the marking scheme by the end. Okay, so the first approach is talking about how this reaction actually happened, is the neutron turn into electron and proton, and try to compare their mass. I think that may be the best. Alright, or just compare neutron and proton. I mean, if you look at this two, they are different. Alright, question 5. Obviously something to do with waves, and when you see the question intensity minima, of course you should record destructive interference. And then if you look forward, you find this is the same as double slit, because when you have double slit, you actually have two sources, alright, that is emitting from the same phase. So you have minima and maxima on the other side. So I guess the number that they give here, you should label as the small d, and this is the big D. And eventually in part 2, I think it will be useful, because this is like the fringe separation. Yes. So you can calculate the wavelength. So we'll do that later. We'll do part 1 first. So it asks you why there's minima, so something to do with destructive interference happened, causing the amplitude at that point to be 0. Okay, so talking about the end product first, and then talking about the criteria. When the path difference between X to receiver and Y to the receiver to when is of a length equal to, alright, the general form that we have for the destructive interference, that would be n plus half lambda, right? And then just to be safe to say n is integer. Alright, so we don't know, but you just talk about generally. When there is a minima, that means like a local minimum, that means the amplitude equal to 0, the structural interference happen, and talk about the criteria why it will happen. Alright, next up then, that basically is the equation that we have learned. So just so you want to be safe, I will do that also. Check the equation that you have, that is here, right? S equals to, let's just copy it, S equal to lambda big D over small d, and this is 7.2 cm. I think the rest are also cm, yes, so then we can just keep it as cm. Lambda we don't know, big D 54, small d is 12. Okay, and so you can resolve lambda. Lambda should be 1.6 cm. Next up, something to do with polarization, I believe. So they have tell you the distance between them, identical antenna, blah blah blah. Why is it need to be parallel? Okay, so since I think something to do with polarization, obviously, since the radio waves are polarized, the plane of oscillation would affect the intensity received. Okay, to keep or to maximize the intensity received, the antenna should, I would say both, well, I think that's obvious, should be parallel to each other. I think that's all. Well, I guess if you really want to, then you can say that if there's an angle, then the intensity will be following the Malus law, which is I equals to I log cosine squared theta, and obviously these cosine squared theta is a number that is between 1 to 0, right? So it would definitely be smaller if angle does not equal to 0 in this case. Alright, next up then, they said, oh, actually it's been misaligned by 30. Okay, power received in a new position, receive, right? So the other side, so that is I, right, that we have. Calculate power that was received in the original position. So that means original, that means like where before you misalign, right? So that is also the same as the one that is being emitted, I believe. So we would say I equals to I log cosine theta square, and then I is the one that you actually now got received, so 12 mu I log cosine square 30 degree, and I think solving it should tell you the original one. So that should be 16 mu W. Yeah, that should be the original one before you misalign, and that's the same as the one that is being transmitted also. Part 2, calculate the minimum time between the wave, blah blah blah. So I think that's simply wave equation because they provided you the distance, very far, 56 km, and that's pretty much it, right? We have the wave equation. Actually, not wave equation. It's just simply v, or speed, equals to distance displacement over time. So v, you know, is 3 times 10 to the power of 8. Distance 56, right? 56 km. So 56 times 1,000 over time t. Between, so I guess just one way, not return trip. So yeah, just calculating this. So the answer would be 1.867. I guess we will take 2 sig fig times 10 to the power of -4, so 1.9, sorry, second. Alright, next up, something to do with chapter 6 probably, gravitational field strength definition. So the definition, if you try to talk about in equation, then should be G equals to F over N. Wait, no, F over mass. So yeah, that's something you should be able to find, I think. Alright, because I just record, yeah, here. So you can say this is force per, I should say more precisely, gravitational force per unit mass experienced per unit mass. Basically it for a small point mass. I think that's all I can say. State the SI unit. So obviously that is Newton per kg then. Yeah, very simple. Okay, next part should be a very typical question about the sun and something is orbiting around it as the circular motion, and so you should have started with F equals to ma, right? Applying in most of the cases, and then the force is gravitational force Gm, big M, small m, I believe, right? Okay, we don't have the planet's mass, but then we can keep it as small m. Big M, small m over r square. You can try to check your data booklet if you don't remember. And then this m, and you know these 2m is going to be cancelled out. As for A, since you are doing something to do with the period and radius, so I guess you need to check, because if you remember, there are four forms of centripetal acceleration. So here is one, here's another one, here's another one, and there's another one that you can deduce using this one, or change it to frequency. But then here, this is the one that we want. So 4 pi square r over t square. Okay, and this should be able to deduce you the whole thing. Put t as one side, so t square equals to, since this is deriving, so you want to show a bit slow, I believe. So r cube gm, okay, and hence t will be square root the whole thing, and then put them back. Oh, this is a big R. Sorry, then I guess we have to change it to big R for this. Okay, and that's it. Part 2 is that the Earth orbit around the Sun is almost with a circular radius. That is this one. So this is a big R that we have. Well, obviously, this is a question that you need to use the previous part. Even they didn't say it, I guess it's pretty obvious. You don't have to deduce another equation. So calculate the mass. So this is a big M that we have. So by applying what we have, so by t squared over, I'll just copy again. Or actually, I should do the square root that one. Right, I'll copy again, because you need to let people know what equation you're using. And then we should have R, we should have M, we should have G, and then, wait, what are we trying to find? Oh, we want to find M, sorry. Yeah, we want to find this. And so we definitely need to know G, which is from the data booklet. We definitely need to know the T by your common sense, all right? And you need that, all right? You are expected to know that the Earth orbiting the Sun, that is the orbit for a year, all right, on our Earth. So that is 365 days. I think that is a good approximation. Some of you may argue, hey, since for each 4 years there's one extra day, right? So technically should be 0.25. All right, or there's an even more precise one, but then 0.25 is pretty good already. But then I feel this is not necessary, so I'll just keep it as 365. So it's up to you. You should find the answer probably the same if you keep it as 365 anyway. So this is day, 1 day, 24 hours. 24 hours, each hour has 60 minutes. 60 minutes will have each minute will have 60 seconds. So that should be the period that we need in second for SI unit. Okay, so this is important. And then the rest you can just find it from data booklet. R is the one that they have given. Cube. G, and from the data booklet, that is right here, I think. 6.67 times 10 to the power of -11. Okay, and then M. So eventually use your calculator. Okay, I hope I pressed it correct. The answer is 2.00x6 something times 10 to the power of 30. So keep 36 fixed, so 2.01. I think that's the correct answer. Next up, something to do with circuit, obviously. And then here we've got an ohmic one, which is a straight line, and then non-ohmic, which is a curve. State how resistant T. T is the one that is curvy. Varies with current going through T. Okay. So obviously we just try to describe what happened when. Okay, maybe I think we should look at the point first. So first of all, this is a I against V. So that means the slope is I over V. And if you recall the Ohm's law, V equals to IR. R is V over I. So that means the inverse of the slope. Alright, or the slope is the inverse of R. So at the very beginning, varies with the current. Okay, so we have to talk about current, I think. When currents increase, obviously, right? When current increase, the resistance of T, okay, either go higher and higher or smaller, obviously. So then we should see this point, say this point, and this point. And then if you remember, when I told you, I said don't take the slope of the tangent for circuit. Don't do that, because by definition it's just simply V over I, alright, for resistance. So what you may do to think is you draw a line to the origin, and then you can judge the slope of this. So obviously it is getting steeper, so that means the slope increase when I increase, right? When you go higher, yeah, I increase, the slope get steeper, and that means, cause it's inverse, right? That means R would decrease instead. So that is the plan we should go for. So the resistance of T decrease. Yeah, I think that should work for 1 mark, right? Decrease. Yeah, should we talk about the rate? If you really want to talk about the rate, I think decrease in the decreasing rate, but I think we don't need that. I think that this should be good enough. Next up, it asks you which one will have a greater resistance at 0.4. So I guess what we have to do is to find out this point and this point and try to draw a line if you want to illustrate it. And you should find the one for T, right, at this point will have a greater slope. Yeah, it's steeper. So with greater slope, just like how we deduced earlier, then resistance should be less. So yeah, that's how you should do. Again, you should not be showing the calculation, so you should show how you can find this. So what we can say is by the slope, I should say the slope from, maybe say for T, the slope from I equals to 0.4 to the origin is greater than the one for the other one, which is R. Since slope represents inverse of R, the resistance of T is smaller than the 1, then the resistance of R. Alright, next, the slider of Z. Okay, here's a potentiometer, move from Y to X, okay, to this direction. Say what happened to the magnitude of current in the ammeter. So both meter are ideal, so you don't have to worry about that. Okay, and so this is the current coming out. It will go through here and also go through here and also go through here. Okay, and then they merge. Alright, and so if that is the case, then we would have, say this is R1, this is R2. Alright, if we split XZ and ZY, right, this is what happened for potentiometer here. This is R1, R2. So while you are moving towards X, then resistance 1 is going to decrease, resistance 2 is increasing, and so that will affect the voltage across this, and of course the current as well. So since we have this as a potential divider, then the voltage across this voltmeter should also decrease, because if you have less resistance, you take less voltage. And so if that's what happened, R doesn't change, V decrease, then I will also decrease. So in total, I believe current would decrease. Number 2, estimate with an explanation voltmeter reading when ammeter is 0.2. Okay, so remember this ammeter is measuring the currents going into R and T in total. Okay, in total. And I think this is something to do with the graph that we have earlier. Okay, so you have to find a line that the currents for each R and T with the same V, and the total will be 0.2. So what we should draw, okay, again I'm going to erase this so that it can be seen to you easily. You want to find the same V, so you're drawing a straight line vertically. Alright, so they will be of the same V. And then you have to draw a line so that that 2 point will have the total of current 0.2. Yeah, 0.2. So obviously it cannot be this point, because for R is already 0.2. So it's probably something like this, maybe? This and this? I think so. Yeah. Free grid, yeah, that is the one. Let me zoom in a bit more. Okay, this is free grid from 0.2, this is free grid from 0. So yeah, they usually are like, they don't make it so tricky for you to read, so it's definitely this one. Okay, so that means V voltage is 0.2. Okay, so what you can say about it is, by the graph, I think there's a figure. Do they? No. Oh, unfortunately. By the graph in part A, maybe. When V equals to 2, yeah, 2.0, the current through, let's just talk about each of them. So through R is 0.14. Yeah, 0.14. 0.14 A, and the current through T is 0.06 A, which gives a total of 0.28. Yeah, so that's why voltage is 2V. Alright, next up, I guess it's something to do with chapter 8, energy production, but then the first one is asking you the electrical power output of the power station. So it gives you a list of data, okay, and I guess you need to check the unit carefully. Okay, so rate of consumed, this is how much natural gas is being consumed, this is how much energy it carries, efficiency, mass. I think we just have to multiply everything. Wait, power output, so not for a year, I believe. It's something to do with power, that means watt, right, or joule per second. So this, we have megajoule, we have kg, so yeah, if you multiply this, then you get megajoule per second. So that's, yeah, I think that's pretty much it. But then there's an efficiency, right, because it's output, so efficiency, definitely we need to count it. And then the last two are not relevant for now. Okay, so we just multiply them. So we have power 14. I think for this case we would, you can, if you want to, write the unit as well. Okay, so eventually you can see that the kg will got cancelled out, and then leaving you with the unit of megajoule per second. That's the power. The answer, the numerical answer you get is this one. Okay, and if you like to run it, so that would be 3 sig fig. So yeah, here's the answer. Alright, next it asks you how many CO2 in kg obviously generated in a year, if assuming they run continuously. So the last data give you in second, how many seconds in 1 year, and here I think you can get how much energy it produce. Wait, no, how much consumed per second. So yeah, so each of these natural gas, you have to multiply them obviously. So this multiply with 2.75. is the one that for each kg of natural gas you produce 2.75 kg of CO2. Alright, that's a lot. Yeah, per kg. Yeah, that's right. And then this is for 1 second, right? So the whole year you have that many seconds. So that will be the answer. So we have 126x74000. Right, or you can say 1.27 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9 kg. Part C, using the answer in BY, countries are being asked to decrease their dependence on fossil fuels, but these are natural gas. I think they are saying the same thing. So obviously the emission of CO2 is huge for when using natural gas or fossil fuel for power generation. CO2 is greenhouse, is a kind of greenhouse gas which will enhance the effect of climate change. And then global warming, I think. I'm not sure if that's good enough. Part D, wow, this is very simple. You even learn it in IGCSE. So the thermal energy of the burning gas will be transferred to the water as thermal energy also, like if thermal energy by heating the water up. The water will become steam which can drive the turbine in a form of kinetic energy. The movement of turbine will, or the kinetic energy, simply the kinetic energy of the turbine in the generator will be transformed as electrical energy. Yeah, I think that's pretty much it. I guess if you really want to, you may also talk about for generator how the Faraday's law is related, but I think not necessary because it only say energy transfer. So focus on talking about what type of energy is involved and what is the energy carrier. Oh, so that is all for the whole paper. I feel it's quite straightforward and quite a lot of calculation actually, like not many explanation that we need. I think on average, right, this is a paper with too much calculation than explanation. In some paper I think it will be the other way around. And I feel most of the questions are quite straightforward too. Okay, so let's look at the answer and see if I make any mistakes. Alright, so here we go with the first question. I think we'll just check the answer. The answer is 6.7. Wait a second, 6.7. Why? 15 sine 50. Yeah, that's correct. Wait, did they use 10? Oh, they used 10. Okay, so scared me. I used 9.81. Right, they used 10. I think that's the difference. Yeah, 6.2. Yeah. Wait, cosine? I used cosine? Sine? Wait. Wait, 15 cosine. Wait, did I press it wrong? Sine 50 times 15 square plus 2 answer divide 2 divide 9.81. Wait a second, did I press it wrong? What? That would be a huge mistake. Oh my god. Divide by 2. Oh no. Oh no. Oh no. I just pressed this wrong. Oh my god. So 6. I don't know why. I thought I did it right. Okay, 6.73. And so this will be 6.73 plus 1.5. Oh no, so actually it is going over. Alright, should be greater. Okay, so it's hitting. Oh my god, it's a huge mistake. Right, so I think it should be hitting, I believe. Yeah, but then they would say correct reasoning consistent with data. So I guess in my case, I should get 2 marks. Right? I would not be able to get this 6.7, but I would say I would get this one. All right, with the correct reasoning. Okay, wow, not a good start. Next up, wait a second. Is it because I did that wrong? Or what? 0.15. Wait, why would we get? Oh my god, is there something wrong with my calculator? Yeah, 5.8, 15, 23, 10, -3. Wait, what? Maybe I copy wrong. Okay, oh my god. Not in a good state of doing an exam. Oh my. Alright, very careless. B2 equal to the force, okay, I think equal in magnitude, I think it's even better. Or 38 Newton, I think that's fine. Opposite direction, yeah, so basically what I said. Yeah, I should get both 2 marks. Number 2. Okay, finally something sensible. And then this one is fine. I give it as negative. I think it should be allowed because it depends on the direction you are saying. So should be fine, I believe. Depending on which direction you say is positive. Number 2, 116, yeah, that's correct. And I think, yeah, like I said, there are 2 different ways of doing it. Number 3, atom, molecule, well, of course, total. Okay, yeah, I think I said more than enough. So basically, kinetic energy, potential energy, more. Well, I'm not sure if I say atom, molecule, particles. Oh, maybe I didn't. So we have to talk about off the, well, I thought that was obvious. Do not allow KEM. What does that mean? Oh, okay, total. Yeah, I did. I think I said total, right? Consists of. So that means total, right? Do not allow sum of average K unless. Okay. Yeah, I think mainly I missed out the first one, atom, molecules, and particles. Yeah, which I thought it was obvious. B is 0. Yeah, basically like what I mentioned. And then this one is 7.7K. Yeah, that's right. Although the number is a bit too small. And then for Spanish, okay. For this one, hypothesis explain. Okay, they didn't say very precisely what, like in a sentence, but I feel that is explain, I guess, to simulate. I think that's what I mentioned, so I feel my answer is good enough. Okay, -1, okay. And then du w minus e, yeah, that's correct. I think if you don't write negative, it's alright, yeah. Label, yeah, E or E negative. Yeah, because if you don't write E negative, it's assumed to be electron, which is negative. In the data table, I think they didn't write it, right? Yeah, they didn't write it also, but this is electron, right? So, yeah, both are fine. Alright, next one. The K product include electron that has mass. Okay, product has energy that has a mass equivalent. So basically, like what I said, right? The mass defect, right? Having the binding energy released. So I guess I will get marks there. And so, what? Okay, I would not know, to be honest. I feel the question is a bit unfair here because they did not ask me which one. I mean, they did not ask me to determine which one is greater or smaller. So I feel it's a bit unfair to expect the candidate to talk about this. Okay, but that's why the grade boundary is quite low for physics compared to other subjects. Okay, so I feel you could determine this of. I mean, we all know about this. I guess if I go with the original approach, like first approach I mentioned when I was doing it, I probably will be able to talk about this one, or neutron greater mass than proton when I talk about the data booklet. Yeah, but I probably wouldn't be putting that down. Anyway, the trading difference, yes, and then okay, they said this. But I think if you talk about path difference, do not allow unless qualified to odd integer number. Wait, but accept. Okay, accept this one. Okay. So mine is fine. Yeah. So here and talking about here. Yeah. I definitely would know this is a way to say, but I guess for some of you studying at SL, you may not understand this, but then This is the foundation of why we have this equation. N plus 1 over 2 bracket lambda is when the two phrases has a difference of half of the cycle. So this sentence will be equivalent to saying this basically. Oh wait, did I miss? Oh, I thought this is an easy question. Why times 2? Central maximum and oh my god, it's a trick question. So times 2, oh my god. So that's why it's times 2 here. Because this is first minimum. When we normally do it is say, let's say here, this is the central maximum. This is, say this is 0th order. This is the first order. And then the minimum that they are talking about is somewhere like here. So it's more like here to here. So this is only half of the fringe separation. So that's why you have to times 2. Very tricky. Alright, next up, we have, talking about the antenna. The component, I think, we could, talk about Maler's law, which I put down already. And then maximum, I think I went for the alternative 3. So for the others, I think it's self-explanatory. Yeah, okay. And then next one, that's correct. And then this one is correct too. Okay, quite straightforward. Force per unit mass on a small mass, okay. Okay, quite standard. I think this one should be easy. So for sure that I know that must be correct. And then this one, that's right. That's just substitution. And then number 7, decrease when increasing out. That's right. And then here, wait, you have to give number. I thought without. What? Oh, V. Okay, V. For both answer without deduction or with incorrect reasoning. I think you can talk about this one. V equals IR or V proportional R. Okay. So I feel, the way that I said should be correct. Or at least the judgment, right, which one is bigger is correct. So I feel the way that I said here should also be correct. Okay, well, when they say no numerical calculation, I feel I shouldn't refer to number, so that's why I didn't say that, but they did refer to a number. Kind of like cheating to me. Anyway, B, decrease, yes. Okay, but of course I think here there will be reasoning behind. It's not like just that you can determine quickly. It takes quite a few steps to determine. Like I said, when it is 2.0 V, then current are these two. So it's very essential that you should mention each of these and then adding them together to become 0.2A. And then that is correct. I guess you could, unit is required, allow use of joule per second. I think using megajoule is fine as well. Here, that's right. Okay. CO2 linked to greenhouse gas. Okay, that's I did. Leading to global warming. That's I did. Okay, I put up this. Basically I put up both. So you can see how I try to phrase it. So it should just be safe, right? In case that word somehow for some reason they don't acknowledge it, there's another word that can help. D. Internal energy of steam particle, KE of steam, KE of turbine, KE of generator dynamo producing. I think so. Because it requires 2 only, right? So definitely I could get it. If it's a 3 total, then it depends, right? Because I didn't mention about KE of generator. Because the turbine itself is part of a generator, I feel. right? Of course, you can talk about the wire itself as well. So yeah, maybe. Dynamo, in case you don't know the name, is the same as generator basically. Okay, so I think overall the whole paper is straightforward, except I honestly make some stupid careless mistake. Alright, for I don't know why really, like for the first question, although the approach that I put is correct. And then the only controversial question I would say is more like this one. It's a bit unfair that you have to say which one is greater than which one. So that's why I usually recommend you guys to have a strategy that is try to do the whole paper within the time. So let's say this paper is 75 minutes. So maybe try to aim to finish it in 1 hour, and then or maybe like leaving maybe 5 to 10 minutes at least at the end. And then when you try to do like question like explanation, go back to add something more. Alright, so you never know, maybe sometimes that it may help you, just like just now that question, right? You have to say, oh, proton heavier than neutron heavier than proton, that question. Right, or anything that you can add, it will always be better, even like this question or even like this question. So that should help to make to maximize your performance in paper 2. So that is all for this paper walkthrough, and I'm not sure if you like this format, and I guess I genuinely show you sometimes I also make careless mistakes, so forgive yourself if you did that in the practice. Of course, try to reduce it, right? I mean, you just want better performance, of course, right, in the exam. So try to think of different ways to help you. Maybe double check. I guess if I have time, if I go and double check it, I probably can find out I make a mistake there. For this one at least, probably not for the fringe separation, this one, because I was conceptually deceived by the question. But then for some question, maybe you can, right? And I also show you sometimes I struggle, and there are questions that it may not give you the best wording, and so you may misunderstood or you don't understand fully what they are asking, and that happened to me as well. So yeah, understand this is something that I also struggle as you also experience too. If you still find there are something that you don't fully understand in this question, or now you understood but then you want to look at a more fundamental concepts, then I will put the link from my videos to each of these questions. So for each question, I'll put up some links that is relevant to that concept that involved in the question in the comment section below, so you can go and check that out. If you like this kind of videos, and if you want to see more like how I would also attempt those past paper, leave a comment in the comment section below and hit the like button. I will see you again in the next video. Bye.